In the name of Allah, the most gracious, the most merciful, be praised to Allah. Assalamu alaikum wa rahmatullahi wa barakatuh. To continue from where we have just stopped, the other lesson, this is lesson 3 about copper metal. And what do you know about copper metal? Copper, the chemical symbol of copper is Cu. The atomic number is 29. Mass number 63.5, which is always rounded off to 64. So copper metal is a transition element. What do we mean by transition element? Transition element are those elements which have got several oxidation states. Like, for instance, we can have copper 1 compound or copper 2. Copper 1 oxide or copper 2 oxide. So it has got different or several oxidation states. So it's among the transition element which is found between group 3 to group 12 in the periodic table. There are other transition elements like lead, which we shall be discussing later. So copper metal combines with other elements in which it exhibits two oxidation states. So let's discuss the ores of copper metal. Include the first one. We have copper pyrite. That is the first ore that we're discussing. The second one is something called copper 2 carbonate. Then we have also the third one, copperite, which is copper 2 oxide. And lastly, we have another ore called copper 1 sulfide. This metal has got impurities. So the impurities include, we have got traces of gold and silver. These are the two major impurities. So we have got traces of gold and silver. So let's discuss about the extraction method of copper. In our previous lesson, we said less reactive elements like copper are extracted by a reduction method. So, for instance, today, copper metal, we shall be using a reduction method. And then we shall see when we are finishing this metal, the extraction of this metal, we shall see the process called electrolysis also. So it uses reduction method and it uses electrolytic method. So copper, let's start. Copper is mostly extracted from copper pyrite. Reason being, this is the chief ore. The chief ore, in the example, if you are asked, the chief ore is called copper pyrite. So it is mainly extracted from copper pyrite. What we have already discussed also, before a metal is extracted, we said the ore is concentrated. The ore is concentrated. The ore is concentrated. So the ore which you are talking about, the chief ore, copper pyrite, is ground. The ore is ground into a fine powder, into a fine powder, into a fine powder, and it is concentrated, and it is concentrated, and it is concentrated by froth flotation, by froth flotation. You remember the process of froth flotation? Yes? So, what do we do now? What do we do? You are done, yeah? The process of concentrating is by froth flotation. Is by froth flotation. So then now you have a concentrated ore. A concentrated ore. What do you do with the concentrated ore? The concentrated ore is then heated. Is then heated in a limited supply of air. In a limited supply of air. In a limited supply of air to obtain iron 2 oxide, and to obtain iron 2 oxide and copper 1 sulfide. Copper 1 sulfide. So you will understand this one when you write the chemical equation. When you write the chemical equation. So we're talking about copper pyrite, which is written like this. Copper pyrite, which is a solid, or copper pyrite. You add, or is heated in a limited supply of air. Limited supply of air, we're talking about air being an oxygen gas. An oxygen gas. So what you will get are 2 products. In fact, it is 3 products. The third one is a gas. So the first one you will get iron 2 oxide, copper 1 sulfide, and then sulfur 4 oxide gas is produced. Sulfur 4 oxide gas is produced. Sulfur 4 oxide gas is produced. So this is our first stage of the extraction of the metal. Stage number 1. What do you do with the concentrated ore? The concentrated ore, which is copper pyrite, which you have already concentrated by froth flotation, is heated with a limited supply of air. With a limited supply of air. With a limited supply of air. To obtain what? To obtain iron 2 oxide, copper 1 sulfide, and sulfur 4 oxide gas. Sulfur 4 oxide gas. And when you are balancing, you balance 2, 4 here, then 2, 3. So that's the balancing, yeah? So that's the first stage of the extraction method. Just by use of air. By use of air. By use of air. By use of air. Now stage number 2 of the extraction of the metal is silica. You understand what silica means? Silica we have already discussed. It's called silicon 4 oxide. So silica is added. Silica is added. In your mixture now, iron 2 oxide and copper 1 sulfide and a gas, that's what you have. That's what you have. So silica is added. Now what is the importance of adding into the silica? The silica into the mixture. What is the purpose? It's because silica being an acidic solution, it will react with the base. It will react with the base. It will react with the base. Silica is added. Silica is added, and the mixture is heated. Is heated with absence of air. Absence of air. So what will happen? Silica reacts with iron 2 oxide. Iron 2 oxide to form iron 2 silicate. Iron 2 silicate, which separates out as slag, leaving behind copper 1 sulfide. Leaving behind copper 1 sulfide. Leaving behind copper 1 sulfide. So stage number 2 is now whereby the iron 2 oxide that has already been formed will react with the silica and you form a slag. So let's write the equation. Iron 2 oxide, yes, will react with the silica, which is silicon 4 oxide. Remember, we're writing L because it's already concentrated, molten. So it forms iron 2 silicate. Iron 2 silicate. We have iron 2 silicate. We have iron 2 silicate. So what are you remain with now? This one has already reacted. This one has already reacted. The iron 2 oxide has reacted with the silica that you have added to the mixture. And you heat it in an absence of air to form iron 2 silicate. Now, the copper 1 oxide now, what do you do with it? It is heated in a regulated supply of air. It is heated with regulated supply of air. So let us see stage number 3. Stage number 3. Yes. Copper 1 sulfide is heated in a regulated supply of air. Where some of it is converted to copper 1 oxide. So we had the copper 1 sulfide. Yes? Copper 1 sulfide now is heated in a regulated supply of air. So let's see, this is stage number 3 of the extraction of the metal. Stage number 3. So copper 1 sulfide, yes, which was molten, copper 1 sulfide, when it is heated with a regulated amount of air, what will form here, some of it is converted. Mark the word, some of it, not all the copper 1 sulfide is converted to copper 1 oxide. Some of it is converted to copper 1 oxide, and sulfur 4 oxide gas is produced. Sulfur 4 oxide gas is produced. And when we balance now, 2, 3 here, 2, and 2. So that is stage number 3. We said we had only copper 1 sulfide. So copper 1 sulfide that you had is heated in a regulated amount of air. The copper 1 sulfide now, when it's heated with air or oxygen gas, some of it now will be converted to copper 1 oxide. Some of it will be converted to copper 1 oxide. And then sulfur 4 oxide gas is produced. Now stage number 4, which is basically the last one. What do you have now? You have copper 1 oxide. Now the remaining copper 1 sulfide will be reacted with the copper 1 oxide to obtain the copper metal now. So let's say the copper 1 oxide that has already been formed from this equation, the copper 1 oxide is reacted with the remaining. Yes, remember we said in stage number 3 we said copper 1 sulfide, not all of it will be converted to copper 1 oxide. So the copper 1 oxide that has already been formed reacts with the remaining copper 1 sulfide to obtain the copper metal and sulfur 4 oxide gas. So let's write this equation. Now what will happen here? Copper 1 oxide that you had, copper 1 oxide will be reacted with the remaining copper 1 sulfide, and then what you will get is copper metal and sulfur 4 oxide gas. Sorry, yes, it is sulfur 4 oxide gas. Sulfur 4 oxide gas. And the balancing is here, 2, then 6, then 6. So you have already obtained your copper metal. So, but there's one thing. From our first equation here, what has been formed is sulfur 4 oxide gas. Yes, again, we have sulfur 4 oxide gas in our equation number 3. Then finally, we have sulfur 4 oxide gas. So what do we do with this sulfur 4 oxide gas? The sulfur 4 oxide gas that is produced now, yes, is fed into a sulfuric acid plant, or it is scrubbed using calcium hydroxide. So you have option. It's either fed into a sulfuric acid plant, or it is scrubbed using calcium hydroxide. So let's write the sulfur 4 oxide, that is produced, yeah? The sulfur 4 oxide produced, is fed into sulfuric, it is adjacent, yeah? Yes, into adjacent sulfuric 6-acid plant, or it is scrubbed using calcium hydroxide, So in our contact process, remember, sulfur oxide was produced there. What do? We take the sulfur oxide gas and you scrap it, because sulfur oxide is a poisonous gas. It is hazardous to the environment. So you scrap using calcium hydroxide. What do you mean by the scrapping? We have an equation. The sulfur oxide gas now, since it is hazardous to the environment, you react it with calcium hydroxide. That is the process called scrubbing. So most common equation, this. What do you mean by scrubbing the gas? This is a process where the sulfur oxide produced, yes, the sulfur oxide produced in either contact process or this process of obtaining copper, a lot of sulfur oxide gas is produced. In our equation number 1, sulfur oxide gas was produced. Equation number 3, sulfur oxide gas was produced. So the sulfur oxide gas produced now is reacted with calcium hydroxide, and what you will obtain there is calcium sulfide plus water. And this equation is self-balanced. This equation is self-balanced. Now, the copper obtained in this method, yes, which method am I talking about? I'm talking about the reduction method. The copper obtained in this method, the copper obtained by this process, the copper obtained in this process, that's right. The copper obtained in this process is 97.5% pure. Is 97.5% pure. So this is called blister copper. Very common in the exams. What is a blister copper? Blister copper is a copper that is produced in a smelting process. Yes, heating, yeah? Yes, a smelting process where the blister surface, is caused by the sulfur oxide gas bubbles. So there was a lot of sulfur oxide gas that has been produced in this process. That one will form on the surface of the copper, and it's called blister copper. It is called blister copper. So what do? If you want to get 100% or maybe 99.8% pure copper, what do? You refine it. So it is refined. We said it is this one that's obtained in this process is 97.5% pure. So if you want to purify more, yes, it is refined. It is refined by electrolysis. So that is the reason why when I was starting this lesson, I said copper take up the two methods of extraction. The first one that have already been discussed, that is reduction method, and then that reduction method, it will give us a copper which is 97.5% pure. It is giving us a copper which is 97.5% pure, and we say it's called blister copper. Now, if you want to get a more pure copper, you refine by electrolysis, and it is obtained, and this will produce 99.8% pure copper. 99.8 pure copper. So this now we want to discuss electrolysis. During refining, we take, of course, you must have an anode. In electrolysis, we said you must have an anode. Yes, of course, another cathode. These are the electrodes. Yes, and then you must have also electrolyte. You must have electrolyte. But now you choose. In your cathode, you use pure stripes of copper. And in your anode, you use an impure copper. So that's right. During refining, what is the purpose of refining? We said the importance of refining is to get more pure copper. So during refining, pure stripes of copper, are used as cathode. So in our cathode, we shall use a pure stripes of copper, whereas impure copper is made the anode. So in our anode, what is our anode? The anode is impure copper. What is our cathode? A pure stripes of copper. And lastly, yes, we said copper 2 sulfate solution. Copper 2 sulfate solution, yes, is used as an electrolyte. Is used as an electrolyte. So let's draw that diagram, yeah? Let's draw that diagram. Top here. Yes. So we have yes. So remember we said this is pure stripes of copper. This is impure copper. Yes. This is our anode. This is cathode. I'm doing this. Yes, then we have the electrolyte. Electrolyte is copper 2 sulfate solution. And then at this juncture here, we have something called sludge. Yes, this is a power source. So what will happen? We have our diagram here. We said during refining, we make our cathode a pure stripes of copper, and our anode we make impure copper. And then we have our electrolyte, which is copper 2 sulfate solution. So let's continue. Now, during electrolysis, yes, impure copper, where is our impure copper? Our impure copper is acting as our anode. So impure copper goes into the solution. As copper 2 ions. In short, the anode is eaten up. It will go into this solution of copper 2 sulfate. The anode is being eaten up. It goes into the solution. It reacts with the solution. While copper metal, remember we are interested with copper metal. Copper metal is deposited at the cathode. Now, there are two major equations that are important to us. Equation at the anode and equation at the cathode. So what will happen? Let us write these two equations because they are the ones which are commonly asked in the exams. Yes. So at the anode, what did I say? At the anode, the impure copper, which is the anode, goes into the solution and it loses 2 electrons. So copper, which was impure solid, it loses 2 electrons and it will form copper ions, and then 2 electrons are lost. So that is the equation of the anode. What is happening? Copper solid, which is impure. That is the reason previously why we were making this anode an impure. It goes into the solution and it will lose 2 electrons to form copper ions. Then at the cathode, now what will happen? At the cathode, copper ions, yes, will gain the 2 electrons, that has been lost here, and it will form copper solid. So a red-brown deposit is observed at the cathode because copper metal is deposited. Now I want to ask you one question, yeah, right? What is the change in mass at the anode and at the cathode? Yes? So there is no change in mass. Yes? The change in mass that we're talking about here is this one. The anode, the mass will reduce because it has gone into the solution. The mass that has been lost here, it will be gained on the cathode. So they balance. That's the reason why this one is losing 2 electrons. The 2 electrons are gained by a copper ion to form a copper solid. Now, finally, the traces of gold and the silver. Yes, these were the major impurities. Of the ore called copper pyrite. Collect, these ones collect as sludge, and then Yes, these ones now are the minor impurities of gold and the silver, which is collected as a sludge at the bottom of electrolytic cell, at the bottom of electrolytic cell, at the bottom of electrolytic cell, at the bottom of electrolytic cell. So that's all about extraction of copper metal. We use the two methods of extractions together. Number one, reduction method, where we've already discussed. Then in the reduction method, you will obtain a blister copper. Blister copper, we said, a copper that is not pure. It is 97.5% pure. So if you want to refine, or if you want to make your copper more pure, you do what's called, you refine it in an electrolysis process, whereby the impure copper is made at the anode and the pure extract of copper is made at the cathode. So that is when we are using copper pyrite as the chief ore. Sometimes we can use copper carbonate. How do you do this way? Copper carbonate is heated. All carbonates, when they are heated, they will form metal oxide and carbon oxide. So this one, copper carbonate, when it's heated, you get copper 2 oxide and a carbon 4 oxide gas. So this one we are using a different ore called copper 2 carbonate. Now, the copper 2 oxide that has already been obtained here now is reacted with a reducing agent. So this one is very simple. You get copper and then carbon 4 oxide gas. So it's only a two-step process when we are using a copper carbonate. Next time we shall discuss about the physical properties, chemical properties, and the uses of copper. So thank you so much.